Hello everyone. One of the students asked me to answer the problem that you have on the slide presentation for chapter number 3. And the question is, how much milk do you need to add to a coffee in order to lower the temperature of the coffee? Initially was 85 Celsius degree, to 60 Celsius degrees. So let me try to show you how I will solve the problem, okay? So you have the coffee. Let's say this is your coffee. And the coffee will initially is at 85 Celsius degrees. So that will be initial temperature. Let me write that way, 85.0 Celsius. And you want to have the coffee at the very end. Final temperature will be 60 degree, right? So you need to drink the coffee at 60 degree. And the volume for the coffee will be 200 milliliter. And what else they say? Okay, now we are going to talk about how much milk you need to add to your coffee in order to have the coffee going from 85 to 60 Celsius, and the volume will be 200 milliliter. Okay, let's talk about the milk. Okay, here is your coffee, and here is your milk. We don't know the volume of the milk. That's the question they say here. How much milk? I don't know. So we have to find volume or mass of the milk. That will be the answer for the problem. And then they say the milk initial temperature, T1, or initial temperature, will be 1.0 Celsius degree, which is very cold, by the way. It's almost freezing for the milk. And what else they say here? They say, okay, this is the key point for answering this problem. The final temperature of the milk has to be the same as the coffee, because when you mix both together, they have to have 60 Celsius degree. When you mix both, that will be the temperature for coffee and milk. And then they say at the very end, assuming the density of the milk is the same as the density of the water, and also the heat capacity of the milk will be the same. So what we can do is the following. The volume of the coffee, assuming density equal 1 gram per milliliter, will be, I would say, approximately equal to 100 gram. And also for the milk, I don't know, but once we find the mass of the milk, we can calculate the volume of the milk and answer that. The formula that I'm going to use is the following: Q equal mass heat capacity delta T for the coffee, and the same one will be for the milk. But the coffee will release the heat to the milk, so the heat will be negative. That will be exothermic because it's going from higher temperature to lower temperature. So the process is exothermic. Heat is going from coffee to the milk. And the process for the milk will be endothermic, and this one is exothermic. And then I had to equal the heat being transferred from the milk to the coffee. I'm going to scroll a little bit up this one by doing the following. Heat released by the coffee will be equal to the heat absorbed by the milk. And now we can start plugging all together. We know the mass of the milk? No, that's the one we need to find. We know the heat capacity of the milk? Yes, they give me here, they say and assuming that the coffee and the milk they had the heat capacity of 4.184 joule grand Celsius. So we know. Oh, okay. I'm using this formula just in case you didn't see why I'm placing the heat capacity here. Is because I'm using this formula, and that will be time also the delta T. Delta T will be final temperature. Let me use parentheses. Will be 60.0 minus 1.0 Celsius. And on the left side, we have a negative sign in front. The mass of the coffee is 200 grams. The heat capacity of the coffee is also the problem say assuming the heat capacity of water, which is the same for both. That will be 4.184 joule and grand Celsius. And delta T, I don't have enough room here, but I will try to squeeze my delta T here. Well, I can do the calculation on the side for the coffee. The delta T is final minus initial. Final is 60 Celsius, is where I want to get my coffee, 60.0. And initial is 85, so delta T will be negative, right? Actually, I'm going to do the calculation so I can plot the number there. So the calculation will be, I go 25 Celsius, and that will be negative. But because we have negative in front, because it's an exothermic, negative times negative 25 Celsius will become positive, right? So this negative cancel this negative and become the whole thing positive. I can start canceling all these unit, joule, grand Celsius here, and Celsius with Celsius because this is also Celsius. So the final unit will be in grand. Let me scroll up a little bit and get in the answer. So I will have 200 grams here that multiply 4.184 times 25. I just cancel Celsius with this Celsius. Equal mass of the milk. That's the one I need to find. 4.184 and 60 minus 1 is 59. I don't need calculator for that. And also I can cancel this too because this is the same number, right? This is the same heat capacity. So I have 200 times 25 over 59, and that will be the mass of the milk. And of course, all of this will be in gram, and I'm going to perform the calculation. So that will be 200 times 25 and divide 59, and I go the following. The answer I go from this calculation is 84.74 gram of milk, and that will be the mass of milk that I will use for bringing down the coffee from 85 to 60 and using initial milk at 1 Celsius degree. And then of course when you mix together they both will have the same temperature. So that will be approximately the amount of milk that you need to add. And of course they ask you probably by the volume, and they say also consider the density of water like a 1 gram per milliliter. So you can say the volume of milk will be also, assuming the density is 1 gram per milliliter, will be 84.74 milliliter. And that will be the total milk that you need to add to your coffee. So that's my way to answer. Maybe you can find another way to answer the problem, but that will be my solution for the problem. Thank you for watching, and remember, if you had a question that you want me to answer, just email me the question and I will work on a video, or I can set an online um, video call with you. Have a good day.